In Solid Edge ST5 simulation, we've added the capability to do heat transfer, and with that comes a change in interface. Actually, there's not a lot of change, but I do want to introduce you to, some of the changes that we've had because of this addition of thermal loads and so on and so forth. So the first thing to mention is that if we go to, for example, Solid Edge Options dialog box, and then if we come down to Simulation, you'll notice that we've added heat flux, heat generation, convection, radiation, and temperature default color types. We've also added thermal applied load, thermal constraint load, things of that nature that apply to thermal analysis. So when we come over to create a new study, the first thing you're going to notice in the pull-down menu is that we have also added steady state heat transfer, and then we've added steady state heat transfer plus a linear static where you can do a combined analysis, and then also a combined analysis with steady state heat and linear buckling. So we'll go ahead and just pick steady state heat transfer. And one of the first things that you're going to notice in the interface is we now have thermal loads. We've also divided up some of the loads between structural loads and body loads. Now, previous to thermal loads, we did have a load called temperature, and that has been renamed to body temperature because there is actually a temperature load now in the thermal loads, which works quite differently than the original temperature did. And we'll talk a little bit more about when body temperature is used during thermal loads later on. Now, the other thing that you're going to notice under thermal loads is the new load types called temperature, as I just mentioned. We also have heat flux. If you're in the part environment, you'll see heat flux where you can apply some power, some heat power to faces, individual faces. We also have convection load and radiation load. Now, if we were in assembly, you would also see a heat generation, which is very similar to heat flux in that heat generation only allows you to select bodies at the assembly level. Some other things that you'll notice is when we when we're creating loads and stuff, and you right mouse button click, we've added the create thermal load to the pull-out menu, so you can do that as well here. So it's going to work exactly the same as it did in if you were just doing a static analysis, but we've added all of these thermal loads to the interface. Now, let's just take a quick look at how this might work. I'm going to go ahead, and I've already created a heat transfer study type, study 1. And so I might just, for example, I might just apply a standard temperature. In this case, it's 68 degrees Fahrenheit. So I'm applying a temperature that will never change on that face. I'm then going to apply heat flux on the two outside faces. And in this case, it's set at 100 watts. Now, we already talked about total load, but then in this case, I've identified two faces using total load. That means it's going to put 50 watts of power on each one of those faces. And then I'm going to allow the heat to dissipate through these little blades. So what I'm going to do is just simply walk around and pick these faces to these blades and apply convection load, film coefficient, and ambient temperature. The ambient temperature outside is 68, so we'll go ahead and accept that. And then we can actually run the solve. So it's going to mesh and then solve the heat transfer study and then process the results, and you'll see that we get the temperatures within each one of those areas of the model displayed on our color bar. Of course, when you run the probe, it's going to give you feedback as far as the temperature is concerned. and you're going to see some other things later in the environment that apply to heat transfer. But this just kind of gives you a quick overview of the thermal loads and the changes in the interface. Now, one thing I don't show in this demo because I'm not in an assembly, but for assembly connectors and heat transfer, at least in ST5, we only use glued connections, and that allows the heat to transfer between the different components. And we've also added to the frame environment heat transfer, but the loads that are available, the only two loads that are available in the frame environment are temperature and heat flux. So with that, this kind of gives you just a very quick overview of the addition of the heat transfer capability in Solid Edge ST5 simulation.